So this first problem, if you look at that square root of 2 there, you can see that the decimal, if you typed in your calculator, you get 1.41421. If you look at it even closer there, it doesn't seem to have a pattern. So that's kind of like pi. That's an irrational number. So this, even though it has some rational parts to it, it's going to be irrational. And all real irrational numbers are also real. That's one of the, if you look at the Venn diagram, that's what that would say. This is a repeating decimal. So any repeating decimal can be written as a fraction. Just for fun, I wrote this one as a fraction. It is 8177 divided by 9,999. That's equivalent. Any fraction is also rational. So this is definitely rational. And any rational number is also real. This number is not even real. You can't take the square root of a negative number, so this one is imaginary, which is not a real number. So it's just imaginary. The model situation, you start with 30 gallons of gas, and then you're using up. So you're using, which means you're subtracting from there, 5 gallons per day. So minus 5 per day. So something like that would be the expression. Be sure to use parentheses appropriately. So here you have a squared minus 2 times b plus a. So a is -3, and a is -3, and b is 2. So I'm just going to plug that in. So this would be -3 squared, which is 9, minus 2 times, let's simplify that parentheses, 2 plus -3 is -1. So that ends up being 9 plus 2 instead of 9 minus 2, which is 11. Here again, we're plugging in. So I'm going to use parentheses when I plug in. Instead of A, I'm going to say parentheses. Instead of B, I'm going to say parentheses. Minus instead of B, I'm going to say parentheses. So A is -3. That goes right here. B is +2. I'm going to simplify inside the parentheses here. So this would be -9 plus 2 is -7. Minus, and then 2 squared is 4. The minus is not being squared there. So that would be +7 minus 4, which is 3. Combine like terms, you get it probably, I'm guessing, distribute here. So 6y minus 10 minus 18y. And the y terms will go together. So 6 minus 18 is -12. So -12y minus 10. We need the same denominator to add these like terms or these terms together to simplify them. So I'm going to get the same denominator by multiplying this one by 2 over 2 and that one by 2 over 2. So you get 4x squared. By the way, all this would be over 2 now, plus x squared plus, I guess it would be 6x. And that goes together. That would be, let's see, 5x squared plus 6x all over 2. I would accept that as the answer. That seems like a good answer to get there, all in one fraction. Simplify, check your work. So you have to distribute this negative. You could think of this as -1. That might be easier for you when you do this. Of course, you distribute there. That's a little easier. So 3x minus x minus -5, which is +5, equals 2x plus 8. So 2x plus 5, this one's going to be a weird one, I can tell. 2x plus 8. If I subtract 2x from both sides, something weird is going to happen. Let's see what happens. So that's x. So that goes away, that goes away. We get 5 equals 8, which doesn't seem to be true here. So when that's not true, you say the answer is no solution here. So no solution. Distribute over here. So this would be 5x plus 10 minus x equals 4x plus 10. I have a feeling something weird's going to happen here. 4x plus 10 equals 4x plus 10. subtract 4x. You get 10 equals 10, which is always true. So this solution is, we would just say all reals. Typically, we use the symbol that for all reals. Let's try this one. Distribute, get 3x minus 6 equals 5x minus 10. I guess I'll subtract 3x here. And maybe add 10. I'm going to do 2 steps in one. So you get 2x on the right. You get 16 on the left. Divide by 2, divide by 2. So x equals 8. X minus 6 minus 10. Oh, I'm sorry. I added 10, right? So let's redo that from this point forward. So I got it right to there. So negative 6 plus 10 is, 4. Just catch my mistake. I was like, that doesn't look right. And you can check it by plugging it back in, equals 2x. Then we could divide by 2, divide by 2. You get x equals 2. That looks right. We could always check it, right? So if we plugged it back in here, 2 minus 2 is 0. 3 times 0 is 0. 2 minus 2 is 0. 5 times 0 is 0. 0 equals 0. That works. So you can double check that you got your answer right. By plugging in, obviously sometimes it's a good idea to do that, like if you make a mistake. Here, I would do as a first step, probably multiply by 2. So you get 3x plus 4 equals 22. Subtract 4. And you get 3x equals 18. Divide by 3, divide by 3, and you get x equals 6. Solve for the given variable. So solve for r. You can really do that in one step here. I would divide by p times t. And you basically have it, right? R equals I over pt. Solve for b here. You have a choice as to whether you distribute that or not. I might consider not distributing. I think I'm not going to. It's just going to save me a step. So I have a over 0.5 h equals, that nicely cancels there, a plus b. And then I'm going to subtract a, so a over 0.5 h minus a equals b. Again, I didn't show my work. I guess you just subtracted a there, but that would be the answer. B is equal to that. Different ways of doing that one, by the way. So getting a little tougher here. Let's see, try this one. So I'm going to move this one over. So I'm going to subtract that. So I get v minus s squared equals 1/2 sh. Let's just do this different. You could divide by 1/2 s. A lot of students will multiply by 2 here. I just want to show you what that would look like. And again, I'm not so interested in simplifying everything. In this type of problem, I just want to get the right answer. So that cancels. You get s times h, divide by s, divide by s, and you have h equals that. So solve for w. This one's a little tougher. I think on the right here, you have to take out the GCF. I don't know if you see it, but it would be w. So w times L plus h. So then we could just divide by L plus h. Divide by L plus h. And you get that. Solve the inequality, and then we're going to graph it here. Let's see, we're going to solve this. So let's move the 2 over and kind of distribute here. So this would be 3x plus 3. I'm going to subtract 2. So I'm going to say less than 9. Subtract 3 now. So I get 3x is less than 6. Divide by 2, which is a positive number. I do not flip the signs when I divide by positive, only a negative multiply. So divide by 3, there would be 2. So x less than 2. positive 2, so that's an open circle because it does not include 2, but the arrow points to the left. X, the solutions are less than or smaller than x, so something like that would be appropriate. Here, let's again distribute here. So we have 5 minus 2n plus, I guess negative 4, I should have said negative 4, less or equal to 4 plus n. So you could get, there's different ways of doing this. I'm gonna subtract n, so I get negative 3n over here. I guess plus 1 less or equal to 4. I get negative 3n less or equal to 3 when I subtract 1. Divide by negative 3. When you divide by negative, you've got to switch the directions of the sign. So now it will be greater than or equal to negative 1. And so negative 1, closed circle, arrow to the right. It's greater than or equal to that. Now we got a little tougher here. So if we divide by 3, which is positive, we don't switch the direction of the sign. So x greater than negative 2. And divide by 2, so x less than 3. So you've kind of got both those things true. You might visualize it and think, oh, that's a segment there. That's the overlap between those two lines. But let me just kind of draw it up above. That's what I like to do. So x is bigger than negative 2. Go all the way to the end. X is smaller than 3, so something like this. Go all the way to the end. And I'm looking for the overlap between those two graphs. And so I want from negative 2 all the way to 3 and everything in between, something like that. I would probably state your answer. So your answer is really an interval. You could say it two different ways. This is really the question there, and the answer is simplified. It's really from a lower bound of negative 2 to an upper bound of 3. Or you could say it this way. You could say negative 2 and x is kind of the middle between 3 and that, and so it'd be less than and less than. Something like that would be the final answer, either in inequality notation or in interval notation there. So divide by 6, again, that's a positive number, so that's better. You don't have to switch the sign. It's less than negative 2. Or divide by 5, you get x greater than equal to 1. So this is an OR statement, which means both are true. I'm going to show them kind of up above here. So 1, that's a closed circle at 1, arrow to the right. Negative 2 is an open circle at negative 2, an arrow to the left. OR means anything on this line is true, anything on this line is true. So the actual answer would be there. It can't really be simplified no more than like that's actually the answer. Well, I guess this is the answer. It can be simplified to that. We're getting there. Okay. So you solve the absolute value, so you're going to split it up into the positive and negative case. The positive case is 2x minus 4 equals 12. The negative case would be 2x minus 4 equals 12, but then you have a choice to make. You can either make the whole right-hand side negative or make the whole left-hand side negative. I usually do the left side. So on the left, on the positive case, this is the positive case. You're going to add 4, so you get 2x equals 16. Divide by 2, you get x equals 8. Definitely a good idea to check that value to make sure it works. You can plug it back in and see if it works. Always a good idea, especially with these kinds of problems. Sometimes you find they don't work. Subtract 8, you get negative 2x equals 4. Divide by negative 2. You get x equals negative 2. Something seems wrong there. Let me double check that. So I added 4. Should add 4 here, right? So this is 16, which makes this 8, which makes this negative 4. I think that looks right. Sorry about that mistake there. always check your answer. Like 2 times -4 is -8, minus 4 is -12. Absolute value of -12 is 12. That works. So you can double check it works. That's how you can check it. Make sure you don't make a mistake. I guess for this one, again, we have to isolate it first. Before I start doing that, I'm going to move the 8 over here. So I get 4 times absolute value 3x plus 4 equals 4x plus 8. Divide by 4, divide by 4, divide by 4. You get absolute value of 3x plus 4 equals, I guess it would be x plus 2. Okay, so now we're ready to split this guy up because we isolated the absolute value. So that's a 4 there, by the way. So the positive case is 3x plus 4 equals x plus 2. The negative case is 3x plus 4 equals x plus 2, but we have to make either the whole right side or the whole left side negative. So I'm going to make the left side negative. On this one, I'm going to subtract x, I get 2x. I'm going to subtract 4, I get -2. Divide by 2, I get x equals -1. Great idea to check that answer and see if it works. -3x minus 4 equals x plus 2. Subtract x, it will be -4x. Add 4, you get 6. Divide by -4, x equals -3/2. Isolate first, so divide by -2. Be careful when you divide by negative, that's going to flip the sign. So absolute value of x plus 3 greater than -4. So now this really a great OR. So this is going to be an OR statement. So I'm going to have an OR in between these two. So you're going to have x plus 3 is greater than -4, or x plus 3 is greater than -4, and I'm going to make that side negative there. So it's -4. So this will be -x minus 3 is greater than -4. Add 3, you get -x is greater than -1. Divide by -1, you get x and 1, and you have less than. So it should be x less than 1. So there's an OR statement here. And this will be subtract 3, so that'd be x greater than -7. So we have x greater than -7 or x less than 1. If you graph that on a number line, see -7 and 1. So the -7 looks something like this. X is either bigger than that one, or x is smaller than that one. Well, this is an OR statement, so it's not just the overlap. It's also these points. It's also these points off to the left. So really everything is a solution for this one. Everything on the number line. Literally the graph is everything, and the answer is all reals. I think this might be the last problem here. So I'm going to move the 6 first. So you have absolute value of 2x plus 3 less than or equal to 9. So we're going to be added 6. Split it up into two cases. So 2x plus 3 equals 9. Or, sorry, less than or equal to 9. And then negative 2x plus 3 quantity less than or equal to 9. So if you subtract 3, that would be 2x less than or equal to 6. Divide by 2, get x less than or equal to 3. You have -2x minus 6 less than or equal to 9. You're going to add 6, so that'd be -2x less than or equal to 15. Divide by -2. Be careful when you divide by negative. You've got to flip the direction of the signs. So you get -15 over 2. If you try and graph that, looks something like this. Let's see. So 3 is a bigger number, -15 over 2. So if I graph this one, that would be a closed circle at 3, arrow to left. This would be closed circle at negative 15.5, arrow to the right. Let's see, this is a, let's see, less than, so that's an and inequality, absolute value inequality. And so the solution is the overlap, which is from here all the way to here. Both closed circles, everything in between. And you can say your final answer. I guess on this one, especially you have to say your final answer. That one was all reals, right? Final answer would be really just the interval from negative 15/2, comma 3, bracket and bracket, because it includes those points. Or you could say it this way: x is less than or equal to 3, x is bigger than or equal to negative 15/2. Make sure the arrows go the same way if you do that. Great.